Hi everyone. In this question, we ask you to prove this relation sec square a equal 1 plus tan square a. In order to start this, the answer of this equation here to prove it, we need to draw this triangle here, name each side, for example, a and o and h, and then this is the angle. And the reason I named AOH here is that makes it easy for me to understand or to memorize. This is angle, so this side is adjacent, so it's A. This one is opposite, name it as O. This one hypotenuse is H, but you are welcome to name it any other letter, A, B, C, or whatever you want. The first step here is to define what are sec and what are the tan. So we start with the sec here. Sec A, as you know, it's 1 over cos, which is hypotenuse over adjacent here. But here it's written as sec squared, so we need to square every term here in this relation. So I'm going to write it as sec square A equal hypotenuse over A all squared, which is the same as h squared over A squared. So now we defined sec A. Let's look to tan A. We know tan is equal opposite over adjacent here. But here it's appeared as a square, so I'm going to make every term squared here. So tan square A equal opposite over A all of squares, and this could be written as opposite square over A square. So now we have done the first step, which we should define the sec A and tan A. Let's go to the second step. This is we have to prove this right hand side equals the left hand side. We are going to start with the right hand side here to break it down here. So 1 plus tan square A equal what? It's 1 plus, yeah, you know it. You know tan square already. We written here as O square divided by A square, isn't it? But we can't add O square over A square plus 1 here. The denominator must be the same, isn't it? This is from fractions rule. So 1 could be turned as A square divided by A square, because A squared divided by A squared is 1, so it's nothing changed. And meanwhile, we make denominator the same and then carry on, plus O square divided by A square. And usually in addition, always in addition fractions, denominator is still the same. So we could rewrite this as A square plus O square divided by A square. So far, hope everything is clear, because the next one is a very important one while we are using Pythagoras here. Pythagoras relationship, you know, this side plus this side equal this side square, isn't it? So here we can say O square plus A square equal hypotenuse square. But you will find out something interesting, that this one, which equals this one, it is the same relation we wrote it here. A square plus O square here, and here O square plus A square. So both of them are similar. That means I can replace this one by the value of this one, which is hypotenuse square. So I can replace this one by hypotenuse square. So I can rewrite 1 plus tan square here as A square plus O square over A square. That's what we already have done before. And we replace A square plus O square as H square divided by A square. And interesting thing, H square over A square is exactly what we have started with, which is the sec square. So I can replace H square divided by A square by sec square. So now we proved that 1 plus tan square A equal sec square A. Hope this is clear. If you have any issue, just contact me. Thank you.